We are working with our factorization. We are going to see that this is an important part that we also have in our syllabus, which is the application of the difference of two squares. So it's actually very, very important that we understand how to apply the difference of two squares pertaining given two expressions that you're going to be focusing with. Let us just take an example that we have got an expression that is considered as a squared minus b squared. This is referred to as a difference of two squares. All right, a squared is a perfect square. Remember, a perfect square, if we are working with a perfect square, in this case, you are considering a term or a number that you can have its square root, and that square root is actually an exact term or an exact number. If we consider numbers, let's say we've got a 4. If we determine the square root of a 4, we obtain exact values, which is plus or minus 2. Let's say for plus the square root of 9, which is plus or minus 3 in this case. All right, we can actually determine the square root of any number as long as the number that is under the square root is greater than 0. We can consider those square roots as plus or minus of a certain value that you're going to have, right? So let us consider that we have got two terms that we have, and these are perfect squares. Like what we have here, we've got a squared, and here we've got b squared. And the difference part that we are referring is the subtraction. All right, we do not have a condition of direct terms for the sum of two squares. For the sum of two squares, it's actually impossible for us to factorize this unless you are talking about the sum or the difference of two cubes. When you're dealing with two cubes, you are going to see that there is a sum and there is a difference of two cubes. But for the two squares, we only have a difference. We do not have a sum of two squares that can be factorized. All right. So what I'm trying to say is that when you are given this part, we can simply have this as a formula that you can have for difference of two squares, which is given as a minus b plus into the bracket of a plus b. Where is this taken? We can actually are wondering, where is this actually taken from? We are simply saying, since this is a perfect square, we are going to determine the square roots of these perfect squares. So we are going to determine the square root of a squared. We are going to determine the square root of b squared, remembering that the square root of a squared is equal to a. All right, the square root of b squared is equal to b. So we just determined the square root of a in one bracket minus the square root of a squared minus the square root of b squared in another bracket. You do the same thing, the square root of a squared in one bracket plus the square root of b squared in another bracket, which is from these two terms that we are having here. So the square root of a squared means from our exponents, that's a squared. Remember, to the exponent, the square root means to the exponent of a half. So if you multiply 2 times a half, in this case, you're going to obtain a to the exponent of 1, which is same as a. So that's why we end up with a. It is the same thing as the b. We are going to have minus b, and the same thing that we have here, but only that we are going to have a plus. So if you have to check, this part here is one and the same. I just want you to prove this because it's not like we are working something that does not exist. Whatever that you're talking about the difference of two squares, it's something that does exist. Remember, we referred to expansion of brackets, where you are expanding brackets or you are given a certain condition and there you are expanding the given brackets. I want you to check that part of your expansion of the brackets. If you had to work with these two brackets, what were we going to have at the end? All right, let us have a vice versa, a minus b into a plus b. We want to expand these two brackets and see if truly we are going to have what we have here as our difference of two squares. All right, so remember, from our expansion, a is going to multiply everything in the other bracket. So that means I'm going to multiply everything by a and the second bracket. So that's a times a, which is going to give us a squared, a times b, which is going to give us plus ab in this case, right? We are just multiplying a and b, that will be a plus. We are done with the a. We move on to minus b. It has to multiply a and also it has to multiply a b. So meaning to say we are going to have minus b times a, which is supposed to be b minus ba like this. But since here we have written in terms of ab, we are just going to write also this as ab, which is minus ab. We're just going to interchange this. It does not affect anything about the sign that you are given. So the sign is going to remain as it is, but you're just trying to write in the same way that you wrote the previous one so that you can properly see that these are like terms, right? So that is what you're going to have. Then we can multiply the last part, that is minus b and plus b at the end. So it's a minus and a plus, which is going to give us a minus, and b times b is b squared. So that is going to give us minus b squared. So if we are to consider here, we've got like terms that we have here, which is plus 1ab and minus 1ab. So plus 1 minus 1 is going to give us a 0. So that means at the end, we are going to remain with this part and this part as part of our answer, which is going to be a squared minus b squared in this case. So as you can see, we are having back exactly the term or the expression that we had before of a squared minus b squared. So it's not like this formula that we are seeing here, it's a formulated thing that was just generated and you're supposed to memorize that, and you wonder, what are you actually memorizing? Where is it taken from? It's something that you actually had before. And if you consider that, you can see it's one and the same thing. All right, so let us check our questions on the difference of two squares. We have got typical questions like what we have here. The first part on A is factorized fully, and we are given the question number 1, where we have got x squared minus 16 in this case. All right, so if you have to consider 16 is a perfect square, so we can prove that. We've got our calculator, so you can have that and check if you have the square root of 16. So you can say square root of 16, which is a 4. So that means this is a perfect square, because this one, we can have its square root, which is the square root of x squared, which is x. So that means we are going to have two brackets in this case, the square root of x squared, which is x, the square root of 16, we saw that it gave us a 4. So one is going to be minus, another one is going to be a plus from the square root of this. So we're actually determining the square root of this, the square root of this. One bracket is going to subtract, another bracket is going to add the square roots of these two terms that we are given. So that's how we can simplify any question that you be given. The same thing here, we are given on question number 2, that is x squared minus 36. Is 36 a perfect square? If you're wondering this, you can just check from your calculator if you can determine the square root of that, but you're supposed to know this by head, that this is a perfect square or not. So the square root of 36 is a 6. That means that is a perfect square. So we are going to have the square root of x squared, which is x, the square root of 36, which is, we saw that it's 6. So this will be x here. We've got minus 6, and the other part is going to be a plus 6. All right. So if you are to consider this way, that you are putting the square root, it's fine. You are saying the square root here, it's x, the square root is x, and the square root of 36, which is 6, another part, it's minus 6, another part, it's a plus 6. All right, which is okay. But if you consider the formula, because you have the formula in mind that a squared minus b squared is supposed to give me a minus b into a plus b. If you want to work it from the formula, what is the interpretation of this formula? What does it mean? All right, this a is a term that is being raised to the exponent of 2. B, again, a term being raised to the exponent of 2. So as long I can write any number, any numbers in this form, or any terms in this form, I know that I'm just going to take the a here and this b. These are the terms that I have, a and b, just that. One is going to add, another one is going to subtract, because it's a formula that we see, so we can use it direct. So that means if I'm given x squared minus 36, if I want to have it this way, I'm going to have this as x squared. I ask myself, this 36 that I'm having here, which number am I going to use? That I'm going to write that number to the exponent of 2, and I get this 36. So to find that number, you must determine the square root of 36. And the square root of 36, we saw that it gives us 6. So the moment I write this as x squared minus 6 squared like this, it means I'm having the formula a squared minus b squared, whereby in this case, we are considering our a as x and our b as a 6. So these are the two terms or the two numbers that I'm going to consider on my final answer. So I'm going to have this as, like I said, I'm having x, and here I'm having 6. So as we can see, a minus b, it is going to be x minus 6. A plus b, it is going to be x plus 6. So that is the same answer that we have here that we just took direct from the square roots, or you can try to interpret it from the formula. Still, you must have one and the same thing, or one and the same answer, just like the previous case. So it does not matter that the number that we are starting with, or it's not just x like what we have here, the coefficient of x squared was 1. Here, if we check, the coefficient of x squared is 9. This does not affect our factorization as long all these terms that we have are perfect squares. So we can check 9 is a perfect square. The square root of 9 is 3. 4 is a perfect square. The square root of 4, which is 2. So meaning to say this is a difference of 2 squares. If all these terms are perfect squares, take note, if it was 9x squared minus 3 like this, it's no longer a difference of 2 squares because 3 is not a perfect square. So you must consider to say that all terms are perfect squares, all right? So like I said, these are perfect squares, so we can simply have our answer as 2 brackets. We are going to consider finding the square root, in this case, of 9x squared, which we simply find the square root of 9, which is 3, all right? The square root of x squared, which is x. So the other bracket is also going to have 3x. So the first part here does not affect to say it's a plus or it's a minus. Just take your term as it is. But the other part, you have to consider the minus and the plus concept, all right? So we are going to determine the square root of 4 in this case, all right? So the square root of 4, which is 2, all right? But we're going to take it as plus or minus 2. So one is going to be a minus, another one is going to be a plus. All right, the order here does not matter because someone might be wondering, why are we just writing a minus? It's because of the formula that I've written here. The order does not affect. I can even write this as a plus b into a minus b like that. The order does not affect as long you are dealing with what? The same brackets. As long the brackets are the same, the order does not affect at all. So that is how we can have our answers in this case, all right? And also question number 4 is a tricky part to many because we consider 1 as not a perfect square, but 1 is a perfect square because the square root of 1 is a 1. So if you are to consider the square root of 1, you are going to see that the square root of 1 is equal to 1. So that means we are referring to a perfect square. So we are going to determine the square root of this part, all right? So we're going to have 2 brackets at the end, the square root of x squared, which is x, and also x here, the square root of 1, which we saw that it's a 1. So 1 is going to subtract, another one is going to add. So that means we are done. That's how you can simply factorize any part of a difference of 2 squares, as long you can tell that this is a perfect square. All right, so if you consider on question number 5, we've got the same thing, 169 x squared minus 100 in this case, okay? So considering this question that I'm having here, we are going to see that 169 is a perfect square, x squared again is a square, then 100 is a square because we have got these square roots. So you can even test from our calculator. If you're not sure about your numbers, you can consider the square root of 169, which is going to give us 13. The square root of 100 in this case, which is going to give us 10. So that means these are perfect squares. So as we saw that, we can have the square root of these numbers, the square root of 169, which gave us 13, the square root of x squared, which is x. So this will be 13x, and also here, this will be 13x. You consider the square root of 100, and we saw that that gave us a 10. So here we are going to have minus 10, and on this other side, we are going to have a plus 10. So that means we are done. We do not have anything common in these 2 brackets. So that means you have truly factorized fully your given expression. So it is the same thing like what we have on this question, 16a squared minus 121b to the exponent of 2. So if you have to consider 16 is a perfect square, 121 again is a perfect square, just like a squared and b squared. So we can have these in two brackets. So we are going to use your calculator. The square root of 16 is going to give us a 4. The square root of a squared, which is a. So that is what you're also going to have in this bracket, all right? The square root of 121 is going to give you 11. So that will be 11. But the square root of b squared, we have got a b. So we are going to consider that, okay? And this part, you're just going to add plus 11b, which is the same as what you have from the previous bracket. So that is how you work out this difference of two squares, as long all the terms that are given there are perfect squares. Now, you might wonder to say, well, how am I supposed to simplify this type of equation where I'm now given to the exponent of 8 and even to the exponent of 6? All right. If we understand this scenario that we have, we can do it direct, but still the same consideration is that the square root, as long here the exponent that we have is an even number, as long you are working with an even number, it means we can determine the square root of that term. And remembering that from our exponents, the square root means to the exponent of a half. So that means to determine the square root of 8 of x to the exponent of 8, it means I'm having x to the exponent of 8 being raised to the exponent of a half. To the square root is to the exponent of a half. So if I multiply these two here, because I have an exponent, that is going to give us x to the exponent of 8 times a half in this case, which is x to the exponent of 4. So that means this part that we see, it's a perfect square. But like I said, whenever you are working with an even term, if this number is an even number, it means it's a perfect square, right? But once you deal with y to the exponent of 3, it's no longer a perfect square. You can't determine the square root of this direct, all right? So you have to work with what? An even number. So on this one, I can also determine the square root of y to the exponent of 6, which simply gives us y to the exponent of 3, okay? Which means we are just multiplying 6 times a half, which is going to give us a 3. All right, and also the other thing that you can also consider for the square roots, all right, I'm going to need this information here. The other thing that you can consider on determining the square root of any number, or maybe is the square root of any term, I mean the cube root, or it can be square root of any term. Maybe I'm given x to the exponent of 10, whatever exponent that I have. All right, the square root, you simply divide this exponent by 2. If you are determining the square root, to remove the square root, you simply divide this exponent by 2. So 10 divided by 2, that is 5. So that means we've got a 5 there. All right. If it is the square root of x to the exponent of 20 like this, you simply divide. So that's x to the exponent of 20 divided by 2 like this, which is x to the exponent of 10. So that's how easy you can determine the square root of any exponent that you're given. It same applies, maybe it was on the cube root. If it is the cube root of x to the exponent of 9 like this, you simply divide this number by the number in the square in the root sign, which is 9, which is 3 in this case. So it is going to be x to the exponent of 9 over 3. This time you use 3, not 2. So this is going to be x to the exponent of 3 in this case, all right? So you have to consider that part carefully. If you are given any part, it can be 5 inside of the root sign. You have to just consider what you are given, all right? Maybe it's the 5th root of x to the exponent of 25. You just have to divide by 5, all right? So it's this exponent divided by this number. That's it. So these are the typical questions that you just need to understand. So as we can see, these ones, like I said, they are perfect squares. So what you're simply going to do is to have two brackets determining the square roots. The square root of 100, which is 10, the square root of x to the exponent of 8, we saw that it gave us x to the exponent of 4. So it's going to be 10x to the exponent of 4, also this side, right? We move on to y to the exponent of 6, the square root of y to the exponent of 6, which is y to the exponent of 3. So that is going to be minus y to the exponent of 3. Another bracket is going to add y to the exponent of 3 like that. All right. So it can be on a condition. You are supposed also to check your answers. Sometimes you might, after factorizing this, you will see that there's also another difference of two squares. You have to factorize again. But here, if we check 10 is not a perfect square, we can't determine its square root. Y to the exponent of 3 is not a perfect square, so that means we do not have a difference of two squares in our final answer, right? So that is, we are done with this case. All right, let us consider other typical questions that you might be given. And as you can see, it's the same approach that we have even on this case. But on this question, we've got something to consider there before we factorize or before we consider to say, yes, it's a difference of two squares. All right, we remember the golden rule of our factorization. If there is something that is common in the first place, you are supposed to factor out the common term. So if I'm to consider here, I've got x squared, I've got x to the exponent of 4. Here we can see that there's something, x is common. And I said, on a condition like this, you have to factor out the one that has got the smallest exponent, which is x squared, the one with the smallest exponent. So we are going to factor out x squared. In this case, we've got two brackets that you're going to, we've got a bracket, that you're going to have. So here we are going to divide. Remember, what you have factored out, you divide back. So it's x to the exponent of 4 divided by x squared. X to the exponent of 4 divided by x squared. You're going to subtract your exponents because the bases are the same and you're dividing. So that's x to the exponent of 4 minus 2, which is x to the exponent of 2. So that means here we are going to have x to the exponent of 2. We divide this x squared and x squared. So x squared over x squared, as we can see, these two are the same. So we're going to obtain a positive one. So that's a negative because of this term. It is going to be a negative one. Yes, it's true that we have factored out what is common because our golden rule of factorization that you have to factor out the highest common factor if there is a common factor throughout. So after that, whatever that we are seeing here, we must be clearly checked and see if it does not give us a difference of two squares or if it gives us a difference of two squares. So considering this, we can see that it is a difference of two squares. We consider that type of a term on question number 4. So here we are back to question number 4. Remember here. So this is the same part that we are seeing inside of this bracket. So meaning to say, if we are to factorize this, we are going to have two brackets from our difference of two squares. So we're going to have two brackets, right? The square root of x squared, which we said it's x, and the square root of 1, we said it's 1. So we're going to have negative 1 plus 1 at the end. So this is now fully factorized. So if you leave your answer at this stage, it's not fully factorized. You are not going to obtain full marks for this factorization because it must be fully factorized in order for you to obtain the full marks. So that's why they write here, factorize fully. You are supposed to have this to the last part where you do not have any common term to consider. Having a to the exponent of 4 minus 16, again, we are considering this as a difference of two squares because we can see that the square root of a to the exponent of 4, we can have this. Remember what I said for a square root, just divide by 2, the exponent. So it's 4 over 2, which is a squared, all right? Or you can simply say a to the exponent of 4 to remove the square root means to the exponent of a half. So I have an exponent and an exponent. So if I multiply these two, 4 times 1 over 2, I'm going to have a 2 in this case. So that means I'm having the same thing. So, and that means it's a perfect square because we obtain an exact term. So that means here we are simply going to have two brackets to consider. All right, the square root of this, we obtained a squared. So you're going to have also a squared here. The square root of 16, which is plus or minus 4. So we are going to consider negative 4 and a positive 4 like this. All right. Just like the previous part that I explained, to say after your factorization, you are supposed to check your answer if it is fully factorized. So if you are to check this answer that we are having, it is not fully factorized because this bracket here again, it is of a difference of 2 squares. So in order for you to see that it is a difference of 2 squares, you are supposed to be commonly used to your perfect squares. You are supposed to know your perfect squares. 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is equal to 25. These are the perfect squares that we are talking about. So if you know this, you can easily see, okay, there is a 4. So I have a 4 here, which is a perfect square. But now, if you are not familiar to this, you might leave your answer at this stage, thinking that it's a fully factorized because you can't tell between a perfect square and what is not a perfect square. So that's why I'm saying the knowing part of your perfect squares is very, very important. So you can see that 4 is a perfect square and the square root of 4, which is plus or minus 2. So we can factorize this further, meaning to say we are going to have 2 brackets from our difference of 2 squares. The square root of a squared, which is a, and we are going to have a here. The square root of 4, which you get plus or minus 2, so you're going to have negative 2 and plus 2. And like I said, there is no sum of 2 squares. So this part is going to remain as it is. It's going to remain as a squared plus 4. This part cannot be factorized, all right? Unless you are talking about sum of 2 cubes. If there are 2 cubes, we can factorize them further. We shall talk about that as we are moving on together in our revisions, where we are having 2 cubes that you need to apply on your factorization. All right, so it is the same part that we have on the B. Again, we are given there to factorize fully, and we are given in this case the first question, n to the exponent of 8 minus 81 in this case. All right, so if we are to consider, are they perfect squares? This is an even number, so that's a perfect square. 81, do we have the square root of 81? The square root of 81 is 9. So we've got plus or minus 9. So that means that's a perfect square. And like I said, you can determine the square root of any to the exponent of 8 by simply dividing the exponent by 2. So that's 8 over 2, which is going to give us a 4. All right, so that means we've got any to the exponent of f4 in this case. All right, so that's any to the exponent of f4, or you consider multiplying by a half. So meaning to say here, this can be factorized if we determine the square roots of these two terms. We are going to have the square root of any to the exponent of 8, which is any to the exponent of 4, any to the exponent of 4 also here. The square root of 81, which we said you're going to have a 9, that is a negative 9 and a positive 9 from the order that we have. And by extending this, by checking our question, we are going to see that we are also having another difference of 2 squares here, because we are having an even exponent, which is 4, and we can determine the square root of 9. Remember, the square root of 9, that's a 3. So that means we are having another difference of 2 squares to consider at the end. All right, so from this difference of 2 squares, we are going to have 2 brackets for that. All right, so we have to consider the square root of any to the exponent of 4. So that is any to the exponent of 4 over 2, which is any squared. The square root of 9, which is going to be plus or minus 3. So that means the square root of any to the exponent of 4 is any squared, and we are going to also have any squared here. All right, the square root of 9, which we said is plus or minus 3. So one bracket is going to subtract, which is minus 3. Another bracket is going to add, which is a plus 3 in this case, right? Then this part, like I said, we do not have a sum of 2 squares. So this, yes, they are perfect squares, but we cannot factorize this part. So it is going to remain as it is, which is any to the exponent of 4 plus 9. again, you have to check if there is a difference of two squares. This is a perfect square, which is true, but this one is not a perfect square 3. We can't determine the square root of 3 direct. It is not a perfect square. So that means we are done in this case. But if it was a condition that it is a perfect square, you are supposed to again factorize. You again applying your difference of two squares, because the scenario there is that if you have a difference of two squares, you are supposed to apply it so that you are factorizing fully your given expressions. Then, like I said, sometimes, all right, let us check number 2. It's not familiar to what we have been talking about, because we can see that something has changed in this case here. What is it that has changed between these two numbers? All right. The first thing, that these are not as perfect squares. We can't determine the square root of 12 and the square root of 75 direct, right? So if you have to check on your calculator, the square root of 12 in this case gives us a number which is not an exact term, that's a decimal. So that means it's not a perfect square. The same thing with the square root of 75, it's not a perfect square. It's giving us a term which is not exact. So that means we are not having a perfect square in this case. So this is not a difference of two squares. Yes, this is a perfect square, and this is a perfect square, x squared and y squared, but these two are not. So this is not a difference of two squares because of these two numbers that are not perfect squares. So what are you going to do? Go back to the golden rule. Do you have anything that is common? You have seen, yes, that we do not have a difference of two squares, but check between the two terms. Do you have anything common between these two terms? We have between 12 and 75 in this case, which is 3. If you check the highest common factor, it's going to be 3. If we divide 12 divided by 3, we're going to see we've got a whole number there. 12 divided by 3, which is 4. 75 divided by 3, which is in this case 25. So that means 3. We're having 3 as a highest common factor that we can use in this case, all right? So we can factor out 3 in the first place. That's 12 divided by 3. We saw that it's going to give us 4. That will be x squared minus 75 divided by 3. We saw that we are going to obtain 25 in this case, but we are going to have y squared at the end. Now the question is, yes, we have factored out the 3, which is common, but are we seeing that this part that is remaining is a difference of two squares? Because 4 is a perfect square. Remember the square root of 4, which is plus or minus 2, all right? The square root of 25 in this case, which is plus or minus 5. So we now have perfect squares. Remember x squared and y squared, these are perfect squares. So we are now having a difference of two squares in this part that we have after factoring out the 3. So that means we are going to have two brackets from the difference of two squares. The square root of 4, which is 2, so we're going to have 2. The square root of x squared, which is x. So we're going to have 2x also this bracket, right? The square root of 25, which is 5, and the square root of y squared, which is y in this case. One is going to subtract, other part is going to add. So that means we are now having this in a factorized manner. It's now fully factorized when it's like this. So you are supposed to fully factorize your given expressions. Check if there are common terms. In cases like that, you have to factor out common terms and you factorize as far as possible from what you be given. All right, so I want you to try. There's so many questions. You can try as much questions as you can have, and let me know for the questions that we still have a challenge, but let us try to work out these questions. And if you have to check, it is the same thing that you have on number 8, where we are given 2x plus y in this case like this, or 2x plus y squared minus y squared like that, all right, on number 8. So if you have to consider this, this is also a difference of two squares because this is a perfect square. This is also a perfect square because of y, because of 2. So we are going to have two brackets. Remember, the idea is to find the square root of these two terms. So the square root of this, the square root of this, of which to find the square root of these terms, simply we are removing the squares that we are having. So this is going to give us 2x plus y. Also here, we are going to have 2x plus y. We move on to the y squared, the square root of y squared, which is y. So we're going to have a minus. Remember, one part, we subtract, another part, we add. But this, all right, sorry for that. So this is an x here. Remember, this is 2x plus y. So this is 2x like that. All right. So what you're going to consider in this case is the same part like what we had to say. You have to now collect your like terms because you consider the square root of this. You now have your term, the square root of this, you subtract. On this part, you add. But we see that the alike terms, we've got y and y on this part. And here we also have y and y in this part. So we can combine. So y minus y on this part is going to give us a 0. This is 1. This is 1. So 1 minus 1, that's a 0. So we are going to be left with 2x. All right. And this part here, you're going to add again. That's y and y here, which is going to give us 2y because we've got a 1 and a 1. So that's 1 plus 1, which is going to give us 2. So we are going to remain with the 2x plus 2y like this. All right. And if you are to check, we are going to see that, yes, we have factorized, but it's not fully factorized because after adding in this part, we are seeing that there is a 2 and a 2, which is common. So we are going to factor out that 2 out of the bracket. So we're going to have 2x times. We factor out the 2 that is common in these two brackets. So we are going to have 2x divided by 2, which is x. We are simply cancelling 2x over 2 like this. That will cancel, obtain x. The same thing with the 2y divided by 2 like this. This will cancel. We obtain plus y like that. So the 2 that we factored out in this case, if you are to consider we factored out the 2, it is now multiplying the term that is already out of the bracket, which is the 2x. So you can multiply that 2 times 2x, which is going to give us 4x into the bracket of x plus y like that. So some other terms, they can extend to something like that. What is important is that follow the steps, and where there's a need for you to simplify. It does not mean that you just have to write your brackets like this, you're done. If it is possible for you to simplify, you are supposed to simplify as far as possible. So there are so many questions that you can try that I left out, just few questions that you can try to work on and see. But that is the idea of your difference of two squares. You're going to be working with these typical expressions. All you just need is to revise as much as you can and also work with your question papers, all right? It is important for you that you revise also question papers so that you check how do they ask these typical questions from the understanding that you have now. Can you answer any question from this understanding that you have? That is the question. If you can answer any question from the question paper, then it means you are even ready to answer any question that might come in the future. So let us just try to work with more questions. Like I said, then if there are any questions that are still having challenge or still giving us challenges, let us just talk about that questions. Let us mention them in the comment section so that we can work on those questions together as a revision as we are preparing ourselves for the exams ahead of time.